Welcome back. In this video, we're going to look at hydrocarbon derivatives. Hydrocarbon derivatives are a class of organic compounds that have something called a functional group. And a functional group is a special arrangement of atoms that usually don't contain just carbon and hydrogen that confer some chemical reactivity to the molecule. So functional groups are going to modify the chemical behavior, the chemical properties of an organic compound. We're going to look at 4 functional groups. Now, technically, a double bond and a triple bond are also functional groups. We've seen those already because they also add some chemical reactivity to an organic compound. But since we've already looked at them already, we're just going to look at an additional 4 functional groups. And I'll just outline them here in let's do a table. So we're going to look at some functional groups, and the first one is called an alcohol. And an alcohol has this functional group in it. It has an OH group attached to a carbon. So the OH is attached to a carbon here, and generically we write this as R-OH, where R represents a carbon chain. And this OH, the OH that's bonded to a carbon covalently, is referred to as a hydroxyl group. Because it looks a lot like the hydroxide ion, but because it's bonded covalently and not ionically, we refer to it as a hydroxyl group because it doesn't have a full charge on it. It's sharing its electrons. The oxygen is sharing its electrons with the carbon. So this is an alcohol. This chemical would be referred to as an alcohol if a chemical has a hydroxyl group in it. So an OH bonded to a carbon, then we refer to it as an alcohol. Barring that it doesn't have any other higher priority functional groups. So every alcohol will have a hydroxyl group attached to it. And alcohol's you know the word alcohol, and it most in terms of like the alcohol that you can find in beverages, that's ethanol. But there's lots of other types of alcohols. Alcohols are used in antibacterial soaps. They're used a lot in beverages. They're used also as like just the basic building blocks to build more complicated chemical compounds. Molecules like cholesterol. Cholesterol has a hydroxyl group in it. So they're very, very common in biochemistry and in chemical processing and reactions. So that's alcohols. They're going to have this hydroxyl group in it. The next class of compounds are called the alkyl halides. And they, like the alcohols, are going to have one of the hydrogens substituted for another group. But instead of an OH group, it's just going to be not X. X doesn't really represent any sort of element. X represents a halogen. So X can be a halogen. So one of the elements from the halogen group. So X could be a fluorine, it could be a chlorine, it could be a bromine or an iodine. So those are alkyl halides. There's lots of alkyl halides that are produced synthetically, or you can find them in nature. The common ones would be like things like Teflon, the material that you find in frying pans. That's a polymer that's built from alkyl halides that have a fluorine here bonded to a carbon. What's another one? Chloroform. Chloroform has chlorine bonded to carbons covalently, so that would be another alkyl halide. I'll do a separate video on how to name alkyl halides. Anyway, that's an alkyl halide. It adds a little bit of reactivity to an otherwise stable molecule if it was just carbons and hydrogens. Next group that we're going to look at is the carboxylic acid. Carboxylic acids, also very common. You can find these in lots and lots of things are carboxylic acids. Acetic acid, which is the component of vinegar, like 5%. Is it 5%? Yeah, it's 5% weight over volume. That's the concentration of acetic acid in vinegar that you can buy at a store. Citric acid is a carboxylic acid. Oxalic acid. Carboxylic acids all tend to be weak monoprotic acids, but some of them can be diprotic. Carboxylic acids have a functional group that looks like a carbon with a double bond to an oxygen, and then it has a single bond to an OH group. So the combination of having carbon, double bond to an oxygen, and a single bond to the OH group from that same carbon, this is what we call a carboxyl group. And chemical compounds that have a carboxyl group are referred to as carboxylic acids. So in general, if you're going to look for a carboxylic acid, you would look for that carboxyl group. And here I just drew a line structural formula for it right there. So carboxylic acids can be reactive. They add a lot of reactivity to a molecule. They also raise the boiling point because it's got some hydrogen bonding going on now. So you'll see these quite frequently. So that's the carboxylic acid. The last group that we look at in Chem 30 are the esters. And the ester actually looks very similar to the carboxyl group, except there's a big difference. Instead of having this hydrogen singly bonded to this oxygen, which is bonded to the carbon, we have another carbon chain. So the ester will look something like this, okay, where you have, looks like a carboxyl group, except it's bonded to the oxygen's bonded to another carbon chain instead of a hydrogen. So this whole thing is called, the whole thing here is actually called an ester. Esters are kind of cool. In Chem 30, we'll synthesize esters in the lab. It doesn't take very long. It's a pretty simple process. And we actually make esters using alcohols and carboxylic acids. Esters have some really pleasant smells associated with them. So a lot of fragrances and fruity perfumes and the scents that you smell in fruits and other chemicals tend to come from esters. Not just from esters, but esters tend to make up a large part of that. So here when I draw just the generic formula for an ester, I use R1 and R2 to show that these can be two different chains of carbons. Okay, so I'll do a separate video for each functional group, and yeah, that'll be it there. Now, this being said, there's lots of other functional groups in organic chemistry. There's a few more functional groups that just contain oxygen, like there's ketones and there's ethers, there's epoxides. Those are just three. But then there's a whole other range of functional groups that contain nitrogens. So there's amines and amides that you see a lot in proteins and amino acids. There's functional groups that contain sulfur, functional groups that contain phosphorus. There's a lot more than what you see just here, and you would encounter those if you were to take an organic chemistry in your first year of university, likely. So anyway, that's for another day and another time and another course, but this is just all we do in Chem 30. All right, see you in the next video where we're going to talk about alcohols.